much aggressive. Okay. Mm-hmm. I don't know who you're watching that. Format that guy. Come on. What is going on? So frustrating. Oops. Oh, come on. Why is it always like this? Okay. Un momento. Un momento. Ninja. Okay. I don't understand that. Okay. Okay, there you go. Okay. 1 second. Okay. Very great. Yeah. That's fine. Mm-hmm. Okay. Tell me about it. Okay. Alright. Area X times L. I'm given this. I think I want to split this down the middle. Y and X. And now I want this. Okay. It's R. That's actually going to be kind of interesting. That's X, that's Y. So the area is 2x times y. And I know that y is the root of r squared minus x squared. It has to travel. It's not that though. So this is L over 2, and this is L. So that line is y equals L minus L over 2x. Right? Right? So there is no R. Whatever, that's fine. But I think this is again like, I wonder if it's a normal to it. Let's find out. 2x times L minus L over 2x, which is then just 2Lx minus x squared over 2. Well, it's an L. L. Okay, let's mini that again. Yeah, that's fine. No, I do twist it up a lot. Let's change that. Okay, let's take the derivative, which is 2L minus x, 2L, that equals 0, when x equals 1. So y is L over 2. So the area, the max would be L. Come on, it's got to be different than that. This is just tripping me out. No, I totally messed that up. Messed it up, yo. Okay, let's go back. So this is not good. That's just this point. something wrong here. And 2xl minus lx squared, which then is 2l minus 2lx, that equals 0 when x equals 1. Yeah, that's not what I want though. So how would I get through this? Let's think about it. This is L, L, L. Everything that goes up. I don't know. It's like why, like that is the point, and it just goes up and down. Like, what if I just don't have that? So then area is x times L, L over 2x. L. The derivative is x. Just 1 minus x. If I set that to 0, I still get the same. What the hell? Grind. So, maximize the area. Why? So, here, maybe that is all it is. Maybe I'm just tripping. So, if x equals 1, y equals L over 2, the area is just L though. Yeah, I don't know. No, it's not. Struggles. That's not even what I want. Doesn't help me. Maybe I read the problem wrong. Man, typical. Just kind of go on, struggle. This doesn't make sense. Man, that is crazy. I think this is just x though. Like, the area is twice it. So when I solve for this, I should get a distinct value. The L just cancels out. And it's going to keep canceling out because there's only one term of it. I get my y equals 1 or L over half. But it's not. So why is it not working? It's inscribed in a fucking equilateral triangle. That's the base. X is half the base. And y. I think, geez, like if I do the other triplet line, y is L over 2 x plus L. And I times that by x. 2x for the area. The area is Lx squared plus 2xL. Take the derivative, the exact same. It's got a negative now. It's not what it is. So, how do I do this? The product is a maximum. But x is a function of L? Like, what if the axis was here? That's y instead. And then this is L. And then what I have here is something. I have x. So then I have L minus x is the void. Times 2. So x is minus 2v's. I don't think I want it like that. I think I want to split the base. So let's split it here. I mean, let's just figure out what this is. It doesn't help me. Not that I can see it. The radius doesn't, I don't even want that. Like, I want the height. I mean, what if I just did y equals the root of r squared and is it the normal? I wonder if that's what it really wants. Like, the line is the normal of it. So it's just 2l squared minus x squared. Right? It might be that. So if it's that, then I can go to my area is 2x times 4l squared minus x squared to the 1/2. And I take the derivative, which is whatever, it's 2 times 4l squared minus x squared to the 1/2 plus 2x times negative 2x times 1/2 all over this stupid thing, which is 4l squared minus x squared to the 1/2. And then I say that equals 0, so I multiply both sides by that. So I get 2 bracket 4l squared minus x squared plus minus, and then 2 strips out, minus 2x squared, and that equals 0. So divide by 2, and that's a minus, yes, and that's a close bracket there. Whoops. Whoops. Let's just multiply that out. And it's just going to get messy. This is then equal to 8L squared minus 2x squared minus 2x squared 0. So that's to say that's 4x. Move that over. Minus 4. That's 2L squared. X equals the root of 2L. And that's half of it. Oh, hey, what's up, man? You've come as I've struggled my way to a solution here. How's your day been? So X was then, oh no, it's root 2 times 2L. I don't think that's it. And then Y. Oh shit. That sucks. Yeah, the desperation sets in. They're like, oh, I've screwed around all year. Yeah, that one's not good. Yeah, it sucks to have to deal with that. And they're just panicked, but then not like really trying. They just want you to give them the answer. It's an equilateral. So yeah, it's L, 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 and it just wants one side flush with the base. And I'm just kind of splitting the coordinate axis, I think. But I keep coming out with like, I feel like I'm dropping something here. And I think like I don't know what's happening. This is a wrong answer. I thought I was on the right path there. So it's like I just need a function for y, and I thought this was sufficient, but it doesn't seem to be equating right. And then I just tried r Like I tried it as if it was like the radius or the hypotenuse. And that didn't really, that kicked me out this one, which is too large. Like it's telling me my x value is bigger than the length of this. Like for some reason, I really thought that would just have been fine. Like I should just keep trying. Not. And then that is y. Like y squared. Hey, what's up, bud? Right. That's not useful. Okay. And then the area of 2x times. Oh, that's not L. Oh. No way. Okay, that's where my mistake is. I don't need all this crap. I didn't think I needed it. Man, simple oversight. Just totally bonkers. So my y-intercept isn't L. It's whatever that is. So that's y equals the root of L squared minus L squared over 4. Which is then just root 3 over 2L. That's the height, right? Which then changes this equation. Man, I cannot believe how silly that is sometimes. And then I have to go down to half an L. So minus I don't really know what I do to minus root 3 over 4. No, I can just balance it. Why not? Minus something times x. Okay, so let's erase that. And L over 2 equals root 3 over 2L minus 0. Qua. X is not 0. Y will be 0. Something. X is L over 2. So I have my slope L over 2. So M is move it times it. So root 3. Drop that. Yeah. Okay, so Y is minus root 3x. Did I put that L in there? No. Okay. Now I think I can actually solve this. Man, you're like a good luck charm. I was struggling with that for well, now it's been almost 40 minutes. Although I was messing about for maybe the first 5-10, but I could not even believe, now that I see what I've done, I just kind of very lazily said that was L, which is, yeah, whatever. But now, minus 2 root 3x squared plus root 3lx, and now that equals 0. Oh, man. Look at this. I'm a genius. Just a really slow genius. Takes a long time to get there. Which is the same as x equals L over 2. Okay, now I just go back to this, and then y equals, no. Why is it telling me my y equals 0? Did I do a mistake? It's frustrating. L over 2. And I subtract this. I have that. Is there a mistake here? 2x squared. It's fine. Multiply that through, the 2's gone. 3x now. Oh my god. Dude. This is silly. It's silly now. Gonna take the derivative. That helps. Which equals 0. Which is, and if x is equal to L over 4. Okay, that makes more sense. Now y equals root 3 over 4L. But x, the actual base, which base 2x, which is over 2. Okay. Oh, man. Yeah, dude, I forgot to differentiate. It's, it's good to practice. It's funny to make mistakes like this. Largest area. Okay. Let's say that. Oh, is that what I want? There's my instinct, but yeah, that makes sense, because then that's R. I just need to find what that is. And then I find what this is. I think that's an appropriate way. By the dimensions of the isosceles triangle, the largest area that's inscribed to the circle radius R. So the height is R plus, I'll just say, oh, let's not use H. L. And my base is going to be X times it's 2x, and x is R squared minus L squared to 1/2. Oh yeah, dude. No, it's one of those things like I think you have to enjoy it, but you also have to like accept that you're gonna suck. Like it's like just like, dude, you're gonna like I used to be able to do this, and I kind of get annoyed that I've forgotten so much. But it like I could just go on pretending like I could still do it, or I could actually sit down and be like, oh yeah, I enjoy doing this. Let's see. I think also knowing, like having the background, actually coming back to Calc 1 and being like, all right, let's do this, it makes it a lot easier. Like knowing how to draw these, or like methods of seeing it, I guess. But messing up like silly things like that is just ridiculous. So now my area, I want to eliminate L. Eliminate L. Eliminate L doing something. Yeah, it's kind of like, yes, it's just like now I'm like super out of shape. Mountain looks like familiar, but you're like, oh, I don't really remember this being that hard. Yeah, I want to get rid of L, I think. So how am I going to do that? And then every other triangle, I need L. A height. Oh, well, let's say radius is just H minus L. I wonder if I can sub that in. I wonder if that works. X equals, and that's H squared minus 2. No, it's not. plus L squared minus L squared. I mean that. The R L this is R minus L. H is just 2R minus R minus L, which is absolute base. Just gives me back R plus L. Yeah, that's a good point. Once you're at that point, you're comfortable with all the material. Mm-hmm. Right, that is L. Right. Wonder. I want it just in terms of R. I think that's the only thing that makes sense to me. And then I eliminate L from X. And then I have H is R plus L. L is, well, in this case, I guess, R, H minus R. And X is now R squared minus L squared. R squared minus L squared, which is H squared, plus 2HR. HR minus R squared. 1/2. X is 2HR minus H squared to the 1/2. This is looking maybe usable. But I still have L in the definition of the height. Yeah, nice isosceles triangle. Right. It's right in the middle. I just don't think that helps me. Well, now just looking at this, it kind of makes sense that like the largest inscribed isosceles triangle is an equilateral triangle, unless like the restriction is that it has to be an isosceles. Like it cannot be an equilateral. It's just by this definition of a triangle inscribed in a circle, and these two lengths are the same. The distance from the center to the corner is always going to be r if the middle of the triangle's in there. Otherwise, it can't touch the corners, or it just can't be centered. And then you have to have it like an uncentered. Like the radius. Did I draw it wrong? No. Like it. Right, I'm just gonna look to see if that's. I shouldn't look. But these are all the same. So this is an equilateral triangle. This is an equilateral triangle, and then this has to be an equilateral triangle. So I just have this where it's all side length r, and this height is h. And that's r, and this is r over 2. So then h is just, you know, root 3 over 2r. So then the base is r. So the triangle's area would be, well, it's half the base anyway, so r over 2 times root 3 over r. Oh, root 3 over 2 r, which is root 3 over 4 r squared. And then I think that, like, I'm not tripping the hell out. I think that makes sense. No. Those jerks. Yeah, okay. That's why I realized doing this and showing that it is an equilateral triangle inside isn't what they wanted. I think they want something like this, where that's your axis and the x-axis, and the radius of the circle is like offset. Like some elaborate peace symbol thing. This is R, 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 and this is double R. Whatever, that's not double R, double bar. Oh. R plus some L. And this is unknown chord. and this is some unknown v of x. And then, yeah, thanks for the compliment there. Helps to visualize. And this is going to be r. So, and this is L. R squared is x plus L squared. So x is just r squared minus L squared to the half. What is going on? And I have this. This is r x L r minus L. And that's this chord again. So I have r squared. I have that one written out. So I have x is also equal to the root of c squared minus r minus L squared to the 1/2. So if I equate those, let's see if this works. I'm probably way off the page now. Okay. Let's c squared. Well, I don't even, c is not even useful. That's a problem. What if I did this differently? Okay, we'll have the chord here. So that's, well, still probably c squared minus r plus L squared to the 1/2. That's c squared minus, oh, let's just multiply that out. 2, no, I still get the bloody, oh, nice. I think, was it Green's theorem? Like, he developed it in an exam. Like, he actually came up with the theorem while he was writing an exam at Cambridge. There's one of them. It was like Stokes' theorem or Green's theorem. Like, so smart. They're just sitting there going like, well, if I just take the integral of a closed area, it's the same as, you know, the volume of a closed area is the surface area of the same integral. I remember learning that and just being like, dude, that is bonkers. some like one of the like exams at Cambridge in the 1800s or something. But he's just like, I'll make a theorem to solve this. I don't like what I'm doing though. It just doesn't make sense. It's like, I'll pursue it a little bit further. But I don't see where this is going. It's not helping at all. I need to get rid of that L. I have do I use Silcatel or something silly on that? Well, that has to be this. Okay, so maybe I can calculate the chord, which I'm working on right now, but it still has L. God damn it. Maybe differentiate now. Like on that, or to differentiate, not on the chord, it's not on that. The chord with respect to R. I want to maximize the area. Largest area. So that's just the chord. Like, do I just like take this with some unknown value and just say, well, the area is x over, or x times h, and x is r squared minus l squared to 1/2, and then h is r plus L. You just differentiate that. Just ignore the L. And then just do a product rule, I guess. So half, and then the r kicks out, so we get r over r squared minus L squared to the half times r plus L plus r squared minus L squared to the 1/2. So that is that. So this is a prime equals 0. This is kind of really messy what I'm doing here. And then I'll strip out that. So then what I get is 0 equals r squared plus rl plus r squared minus L squared. So 2r squared plus rl minus L squared equals 0. And I just take L is such an obtuse variable. Like, that doesn't even make sense why I'd have that kicking around. Solve for L. But I want to know the radius. I can put in here. Oh man. I wonder if I look at it in a little bit different light. I don't know if that's actually it. That's not my slope. I get 0 when I have a slope of that's about yes. Like this right here. I just I mean r is equal to negative L plus minus L squared minus plus 8L squared over 2, 4. So r equals, and it's got to be strictly positive, so negative L plus 3L over 4, which is 2L. L over 2. I mean, maybe I should solve it for L though, like, because I want to eliminate L, not R. So I'll leave that there for now. L is actually negative, so plus R plus minus the root R squared minus, that's positive, so that's negative, so that's negative, so that's plus 4 times that's 8R squared over 2, which is the exact same. It has to be strictly positive. So R plus 3R over 2, which is 2R. That makes no sense. Did I do that wrong? It was minus 3. It just doesn't make sense. Yeah, no. It becomes in handy quite a lot. But also, it doesn't, like, everything's so plug and play that beyond knowing power distribution, like, it comes in handy when you're like building stages and you have, maybe 1600 amps and you're trying to balance all the lights and stuff. But everything's going to LED now, so it's more like computers now. Mhm. Yeah, for some reason. Hmm. Just redoing this. It's silly. I'm like just rereading it. silly. Oops, minus h. Well, what did I have? I had h. Like h had a solution of two r. So x is what? R squared minus 2r squared all in half. Yeah, it's like r squared minus 4r squared. What did I have for h? That's the chord. I wonder if I'm supposed to like do some tangent or something here. I don't know why. Well, at least that gives me half. But I don't even know into that. But it's still the same. It's still just h squared over 4 minus h squared. So I still get that negative. I wonder what I got such a fight. What is going on? Oswald's triangle of largest area. It can be inscribed circle radius r. That? Yeah, give me 1 sec. I think I got some food cooking. here. No, it's not even true. Although I can say that this is gamma. This is gamma over 2. And the struggle is real. I don't think I need to use trig. Not like that. I wonder if that's what I needed. So that's that. And then I can just say that the length is r plus r squared minus x squared. And the area is x times r plus r minus x squared. I differentiate like r is a function of x. Just implicitly differentiate everything. I just don't want that bloody h. I feel like it's not supposed to be this hard at all. Whew. Data can change. Like, what is I just don't think this is right. It shouldn't be this hard. So I'm missing something. These are both functions of change, and sine and cos are just not going to. R squared sine squared. Let's try again. my formula missing a 3 from it. How to calculate the height. So I said h squared is equal to r squared minus squared over 4. And that's 3 r squared over 4. Which is actually what they got for the base. How can I resolve these problems? So if this is x, and this is theta, then x is r sine theta, and then I go to this point, it's half that angle. So x is also r sine half theta. And if I eliminate h, so h is r cos theta. H is not relative to that. And h plus r No, and R changes. What about 10? I could do 10. Oh, shit. And I do x over h is 10 theta. And then I have x over h plus r is 10 theta over 2. Do I have a half angle formula for this? I don't remember. That's not going to help too much. Turn that into 2 10 theta over 2 over 1 minus 10 theta over 2. And substitute that in. So I have x plus, does it, oh, I can solve for r if I can eliminate h. God damn it. Oh, like the last thing I really want to do. So tooth right now. Fair enough. It's a reasonable fight. It's a good fight. I'm in a rabbit hole, but I'm going to dig in. I want to eliminate. I want to solve for h. So that and that's gone. And that's going to be 1 over h equals 2 h plus r all over h squared plus r squared minus x squared. You're going to cross multiply. So then that's h squared plus 2hr minus r squared plus x squared equals 0. That's genuinely obtuse. H equals minus 2r plus minus the root of 4r squared minus, I'm going to write it out, 4a times b x squared minus r squared over 2. So strip the 4 out, and then we'll get minus r plus minus, and then that's 2r squared minus x squared over, that's it. There's not a half denominator. And x is the fucking base length. So height mean, that's not really useful. Like, although that's a, like, x squared is that a perfect square? It's not a perfect square, is it? No. Thought it was. I messed the sign up today. Nope. No, length is just r plus h, which is r minus r plus minus the root of 2r squared minus x squared, which then equals, so it has to be the positive 2r squared minus x squared. It has to be the length or the whatever the total height. I have x. So, x is defined as some stupid thing. Like I could define x, but it's cos. I don't want bloody cos in there. Oh, this problem. I might actually pack it in on this problem. Just call it a day and then sleep on it because I don't want to like this one's gonna bother me if I can't figure it out. Yeah, what could be like okay, like x was r sine theta, I think in this instance. Just to say that's just 2r squared minus r squared sine squared, which is then r, and I have a stupid 2 minus sine squared theta, which is then just r, I'm doing something crazy, plus 1 sine squared theta. I hate the radical sign. Like I hate drawing radicals. 1 root 1, and that's cos squared. And the root of 1 plus cos squared theta. That seems like some identity I should know. Man, oh man. What do they have for their actual lengths? They have this is equal to 3 over 2r. 3 over 2. So I put that as a quarter. 1/4. No, 1/2. A half. A half of r. And that's 4r squared over 2, which is 3r squared over 2. But that's not what I want. I want 4, base 4. So So, yeah, no, that's squared. So something, let's say x equals r over 2, and then L is the root of 2r squared minus r squared over 4, and that's 8. No, see, that's the problem. That's 8. No, that's not going to work. Oh. How do I figure this out? No, I don't want to give up on this stupid thing. Like, it shouldn't be this hard. What am I missing? I'm missing something. It's really silly. Like, here's my triangle. Half. The other half. Really wobbly half. Here's the center. This is the part that, like, annoys the hell out of me. Like, I swear it's going to be an equilateral triangle. That's my chord length. So the total height, h squared, is just equal to c squared minus x squared. That's my total height. And my base is just equal to x. So what's r? Or what's c? C is going to be r, c. So c, I'm just introducing a variable. Just like it's not really beneficial. All squared. Solves nothing. Just bloody nightmare. It's C over 2 as well. Which is twice the size of that. Which then tells me h squared is 4 r squared minus 4l squared minus x squared. It's like it doesn't help at all. Struggle is real. It's worth it. It's bloody hell. Oh. Yeah, I mean, it just wants the solution in terms of r. So it's just a circle with a radius r, and then it just wants a isosceles triangle in it. Um, but I just kind of throw it onto the coordinate system randomly. Well, I don't think it's totally randomly. Like, I don't even know if I need to throw it on a coordinate system. I think that might be the issue. So I don't know if I'm right off the page here. It hasn't really given me any, like, it just wants the area. Like, uh, so I guess oh, that's a terrible circle. Little egg. And there's just some radius. That's literally all it's giving us. And this x is just my base. That's x, and then this is h. Funny. Oh man. Yeah, I've done everything. It's definitely overkill. I'm like digging myself deeper and deeper, but I for sure have defined everything in terms of uh, R and X, and I'm bouncing back and forth with L and H. That's just to define the height. And anytime I use C, it's just the chord that cuts the circle. Because I'm trying to find a way through. But it is an excessive amount of variables. And I only started using theta when I got like dejected. But yeah, uh, like I wanna get the area, take the derivative, set it to 0, solve for whatever's in there, like x or r. Probably solve for x. Solve for x in terms of r. Right, it's a function of r. But x is like x is a function of r as well. So it's like if I make an equation, it's like I have to take implicit differentiation here, and I for some reason I'm really avoiding doing that. I don't feel like that's the right method. But the radius is constant. That's what's going on. It's not a function of x. Is it? No, dude, no, I'm not. Everything you say usually helps. I mean, that's helping me to even think about the problem. Uh, Dude, it is. Okay, let's think about this again. My area is the base times the height. I have some circle. There's an isosceles triangle. And this is my height. Oh my god, that's my height. This has a radius. And this is my base x. R is constant. Oh, I can take these out. R is constant. So I don't need to worry about deriving that. I just want h. So x is equal to h equal to r plus this segment L, and L is the root of r squared minus x squared. Is that it? Oh my god, it better not be. So the area function is x is half the base times r squared minus x squared to the 1/2. A prime is r squared minus x squared to the 1/2 plus, and I'm taking derivative with respect to x, so minus x times x all over r squared minus x squared to the 1/2. Make that equal to 0. R squared minus x squared equals 0. So I have x squared equals r squared over 2. X equals r over root 2. Did I mess something up? Oh man. I'll just draw that out. It's back. L R X. L is, yeah, the root r squared minus x squared. X is that. Oh, but the entire base is equal to 2x, which is then like root 2 r over 2. Is that one? Is that, no, it's just root 2r. What am I doing? It's root 2r. Am I tripping? Yeah. I don't think that's what I got. And then h is the height, and that's root 2r. And h is r plus l, and l is r squared minus x squared, which is r squared over 2 to the 1/2, which is then r plus r over oh, I did right here. Dude, do you know how frustrating? Oh, I'm like trying to go faster than I should, if that makes sense. Like, I'm not being mindful and looking close enough. I'm like acting like I can still do math quick and not miss things, but I miss stuff all the time now. So then this is r plus r squared minus x squared to the 1/2. So then a prime is r plus r squared minus x squared to the 1/2 plus, I'm just going to write this out simply because I'll make a mistake. So that's what I do now. Negative 2x times 1/2 all over r plus r squared minus x squared to the 1/2. Nope, it's not in that bracket. It's outside of that bracket. Okay, and that equates to 0. I multiply this and that, and then what I get is r squared plus 2r, oh god, this looks horrendous, 1/2 plus r squared minus x squared minus x squared equals 0. And then 2r squared, like that's, what the hell is that still doing in there? Did I make another mistake? That rests. I take the derivative of this. Yeah, I was just starting to look at that because once I take the derivative of this, that disappears in this. So this is just the denominator. And then this simplifies. Dude, it's like doing like mental acrobatics at times where you're like, my skills are, whoa, I'm not proud of them right now. 0 equals r times r squared minus x squared to the 1/2 plus r squared minus x squared minus x squared. So let's resolve this. I have 2x squared equals, oh, you know what, maybe I should just, is it going to really want me to bloody do that? Jesus. This is a trick of the problem. 2x squared minus r squared over r squared equals r squared minus x squared. And then that's r squared. So then that's 4x to the 4 minus, let's put plus r to the 4. Why do I have 4 roots? I feel like I shouldn't have something in the 4th power. What am I doing? What is going on? This denominator, usually I can cancel it out, but I'm keeping this bloody r. Whatever, keep going. Oh, it's not so bad because there's an r squared in the denominator. Okay, plus, and then minus 2r for rx. 4rx r squared equals r squared minus x squared. Solve for x squared. Okay, I'm just writing out more because I like. Just do the square of it. Dude. Oh. that was a problem. So I know what that is. So L is now r squared minus 3r squared over 4 to the half, which then is a quarter, which is then just r over 2, which then h is just r plus L, which is then r plus r over 2, which is 3r over 2. Oh, dude. That problem was a lot of paper and a lot of graphite of just problem solving and really trying everything. That was I mean, I feel grateful that I feel good. You know, that feels like a good win. I think I'm gonna tap out though. It's 9 o'clock here, and I gotta be up early to meet a friend. But yeah, I'll try to be back on here a little earlier than today because of Christmas shopping and whatnot. Yeah, dude. Have a good night. I'll see you in the future.